It's my pleasure to introduce our invited speaker, Dr. Zoe Liu, and she prefers people to call her Sunshine, which is a beautiful name. So welcome. So Dr. Liu is a associate professor at Department of Software and Information Systems of the University of North Carolina at Charlotte. So Dr. Liu's research has been in data and text analytics, knowledge discovery and search behaviors, as well as interactive information retrieval. So now we know she knows both. She knows information science as well as computer science now, very much interdisciplinary knowledge. And so I'm looking forward to her talk, which is on understanding faceted search from information retrieval, information science, and data science perspectives. Welcome, Dr. Liu.
Thank you, Haiming. Thank you for the introduction. So my talk today is understanding faceted search from information retrieval, information science, and data science perspectives. The talk is based on a paper published in TWICE last year, which is 2019. I am very honored to give this invited talk because I feel that the talk fits the scope of the workshop very well. So the first thing is that I want to claim the contribution of the paper or the talk. It's actually we combine machine learning models and user-centered approach to study faceted search. And then the second contribution is that we do this real-time prediction of facet use during the search dynamics. So the two contributions are associated with our background. Like I mentioned, I graduated from information school and now work as a faculty member at the computer science department. I recently got a joint appointment in School of Data Science. So I have all the backgrounds here. So the contributions are related to our background really closely. Just to refresh our memory, I believe most of you already know what are the facets. So if we, this is a search page from Walmart. And then if we type a query camera into the search box, and then we will see a lot of search results, a lot of cameras on the search page. On the left panel, we will say some price, brand, megapixels. So those are the facets. And then we also see some options under each facet, like $0 to $50, $50 to $100, and a Nikon, Canon. So those kind of options are just facet values under each facet. So this study is just to investigate how people use facets to help their search. So our research questions are really straightforward. We just have two. So the number one is, are we able to anticipate real-time facet use during a search process? And then the second is, under what circumstances are facets needed? So we select a library as a study case. So this is a library catalog from UNC. And then the reason that we select this faceted search in a library catalog is that we believe, unlike the commercial website, the library's facet implementation is just for the purpose of information discovery instead of, promote something for profit reason. All right. So in order to answer our first research question, we use a machine learning approach. And then this is the workflow or the framework for our machine learning approach. So we do it in a standard way, like log data feature engineering, and then we build a machine learning model, and then we make our prediction and also do some follow-up analysis. So the collection of data is that we have 1.5 million log records from all kinds of patrons in the library. And also we identify the session and action from the log data. We, in total, we have 406,000 sessions and 1.5 million actions. extracted from the log data. And then we do the temporal feature engineering as the standard way for the machine learning approach. Later on, we developed 3 machine learning models: random forest, KNN, and logistic regression. And at last, we check the accuracy, sensitivity, specificity of the machine learning model. And also we do some post hoc analysis, like check the variable importance in the prediction. And also we do this partial dependency. So the important thing is the target variable we want to predict is the time point that a user will use facet based on his previous actions in the same session. So that's our goal. Just to pick up some component from the previous slide, and then we do this temporal feature engineering. We extract some interesting variables from the data, and we extract 5 types of variables and 12 variables in total. And I just want to talk about the 3 of the variables because the 3 are very representative of this the sequential or dynamic way of the prediction. The 3 variables are P to add facet, and then Markov L, and then Markov Disk. So in the following slides, I will talk about each of the variables one by one. So the first variable is a P to add facet. So this is a progress toward the next facet addition. And then the rationale behind this variable is that we believe users tend to follow some search pattern or follow some activity cadence during their search. And then they tend to perform similar number of actions before adding a facet. So that's why we propose this variable. And in order to investigate this variable, we actually propose an intermediate variable first, which is and between add facet. So this is the second bullet point here. That means we want to calculate the average number of actions between facet addition. We do some statistics here, and then we find the mean is 1.3. So that means on average, people will perform 1.3 action before adding a facet. So this P to add facet is just checking the ratio between the number of actions since the last facet addition and the current sessions and between add facet. So this is a little confusing. So for example, the current session add between add facet is 5.5. If last facet was added to the search 3 actions ago, so that means 54% of the progress was achieved since last facet addition. So that's the first variable. And then the second variable is this Markov likelihood. And then we want to check the Markov likelihood value of the next action being the add facet. And then we focus on the first order Markov chain because the literature suggests that the first order Markov chain, which contains 2 actions, the 2-action sequence, has been very effective in modeling online search and browsing behavior. So the figure lists all the probabilities of all kinds of actions leading to add a facet. As we can see, the top action is actually the show more facet. Of course, if the user opens the facet options, and then it's highly likely that the next action is add facet. So that's the second variable. And then the third variable is Markov Disk. It's a Markov action sequence discrimination value. And then we compute the log odds ratio between the odds of observing a sequence S, given it originates from a facet session, and the odds of observing a sequence S, given it belongs to a non-facet session. So it's a log odds ratio. Actually, it's a ratio of 2 odds. So the upper odds, it's actually affinity of this sequence in the facet session, and the lower part is the odds of the sequence in the non-facet session. So we so if you look at the lower equation, there is a long sequence action 1, action 2, until action K, and then we segment each component. We actually make a lot of segments. We focus on this first order Markov chain and make it a series of 2 action sequences. And then we check this log odds ratio, and later on we add them together as a final Markov disk. So the outcome actually reflects affinity of an action sequence with respect to a facet or non-facet sessions. Here is the result. That's the machine learning model result. And then we use 3 models, RF, KNN, and logistic regression. And then as you can see, the accuracy, random forest outperforms the other 2 models. And then if we look at the sensitivity and the specificity, we know that random forest is actually better than negative cases than the positive cases. So that means it's better, at not mistakenly identifying the non-faceted actions into faceted actions than the true faceted action recognition. So that means it's better than negative cases. All right, so machine learning, we feel it's like a black box. It's just gave us overall accuracy. And later on, we check this each individual variable's importance or contribution to the final prediction. And then I listed the result here. As you can see, the most important variables are the Markov L, query entropy, P2 add facet, and Markov disk. So they all play a very important role in predicting the facet use. And the second post hoc analysis is the partial dependency, because in the logistic regression, we got a lot of parametric interpretation from the coefficient, but in the random forest, we lost this advantage. We do not have this parametric insights. So that's why some smart statisticians developed this approach called partial dependency. They actually check the marginal contribution of a variable to a prediction by holding other variables constant. And then we check the partial dependency for all the top 5 variables. As you can see, the relationship of their marginal contribution is not linear, it's complex. And then I just want to talk about this query entropy, which is the second figure on the right side. So if you look at the curve, so if the query entropy reaches 3.5, and then before 3.5, the relationship is roughly linear. And then that means the likelihood of using facet is higher. But after 3.5, and then the likelihood drops. So that means if the query is too broad, and then people will abandon the idea of using facet. People will even abandon the query to refine, to reissue a new query. So that's the message this figure wants to send us. So that's our first research question. And now I will talk about our second research question, which is under what circumstances are facets needed? And then we use a user study to answer this question. And then we recruited 24 participants into the lab. And then each conduct 8 search tasks. And then for the 8 search tasks, we have this 2x2 factorial design, like the simple, complex, closed-ended, open-ended. And then we want to check, under different type of search tasks, is there any difference for the facet use? The right table, I gave you some example of each type. So we actually do a lot of statistics, the numbers between different groups. Because of the time limit, I did not put them here. They are in the original paper. So here I only want to talk about some visualization we did. We developed a visualization software to visualize people's activity during the task completion. And then we find that there are roughly 5 circumstances that people tend to use facets. So the first circumstance is that the they actually use a facet to modify a text query. And then if you look at this visualization, there are 2 rows, and then each row is a search thread under one search query. If the searcher changes the query, and then we change the line, that's the second row. And then each rectangle box means action. So the green rectangle box is the query, and the blue rectangle box means a facet operation. And then the pink means the check record. So here, the user issue a query, Sweet Dreams, and later on add a facet music library, add facet music to modify the text query, to append some specific information to the query. So that's the most common way. And then the second circumstance is that eliminate information they did not want. So the user issues a query, Paramount Pictures, and open the language facet, and then deselect the English option. So that means the user wants all the non-English movies from that company. The third circumstance is that see options from a vague idea. Like here, the user is trying to find some travel guide to the Europe. And then the user open the author facet to say what are the available authors for a travel guide. And then later on, find an author, Bill Bryson. So that means the user's idea is vague, and then he is using the facet to say some options to explore different ways. So the fourth circumstance is using a facet to start an open-ended search. So in this search session, there are only 2 actions without any query. It's just a 2-facet action. And then the user puts the location facet first, and later on put the format facet to explore. So this is actually also open-ended search, but the user rely on the facets completely to do the browsing. So the last circumstance we find is that develop ideas for their next query. Sometimes the users are out of idea of the new text query, and then they may copy and paste from the facet and then paste into the search box to issue a new text query. So that's what this user does in the session. And then if you look at the last query, which is in the last row, and then its author name. This author name is actually copied from the author facet by the user. So here are the conclusions. We actually use 2 approaches to study the facet use. And then here are the conclusions from the both approaches. And then we find that real-time facet use can be predicted at a very high accuracy level. And also we find that use of facets is heavily impacted by the immediately proceeding actions. And also search process typically follows a rhythm flow, which means a search cadence. There is a pattern in search activities. And also facet use is less influenced by the cumulative action history. And facet use is influenced by the initial search scope. And facet use is influenced by the type of search tasks. And facets are used to recognize information from a vague idea. And also facets are used as a way to generate new ideas for search. If you look at the right side, that's actually the different approach derive different conclusions. So that's our triangulation of the 2 approaches. All right, thank you very much for your attention, and I'm open to take questions.
Okay, thank you very much, Sunshine. Any questions?
Yeah, hello, thank you very much, very interesting. I need to go and read the Toys paper, but I haven't done so. That's why I might ask a question that you already answered in the Toys paper. So how generalizable do you think are the findings? Because faceted search is being used in so many contexts, and I imagine that depending on the business, the type of transaction you have in mind, whether you go to the library, whether you want to buy something, whether you want to solve a problem, might affect the way how people use facets and how maybe the conclusions would be phrased.
Mm-hmm. Yes. So we want to get a generalizable results. That's why we are very careful when we select the study case, whether library or the commercial websites. So the reason that we select the library site is that it's actually for the information seeking purpose. It's not for the commercial reason. So that's why we believe this information seeking purpose can be applied to other contexts, to the commercial, to the websites. If you go to Amazon, and then the same thing. If you look at a camera, and then if you add a facet, could it be appending specific information to the original query, could be one of those circumstances I mentioned. So that's actually, although it's from the library catalog, but it's actually abstract enough to cover other domains for the information seeking purpose.
Because the reason I ask is my main reference for faceted search, wherever I check what people have said, is more from a practitioner's perspective, where they look at e-commerce. So Tony Russell Rose and Tyler Tate, they wrote this Morgan and Kaufman book, Designing the Search Experience, with a big chapter on faceted search. And I always go there first. But now if I want to find something about the information seeking community, then I will go to your choice paper.
Mm-hmm. Yeah.
Okay, any further questions? Okay, I have a quick one, Sunshine. How would your findings, the conclusion will be go back to the library? How would you be able to suggest them to do some changes in terms of the system they're using or the design of the system?
Oh yeah, that's a good question. Yeah, we do have some collaborations with the library, and then we do some simple ways and complex ways of collaboration of the project. The simple ways is that actually we experiment different placement of facets in our library. Like according to the study, some facets are highly used, some facets are rarely used by people, and then we actually adjust some placement. So that's a simple collaboration, simple project. That's something we already do. We have already done. And then the deeper way, it's actually something we plan to do right now, and is funded by NSF. It's actually a recommender system. Instead of recommending library books, CDs, we actually recommend a facet for people to use. And then based on this behavior analysis, and then we see some pattern, and then we see some transition probability, and then we actually monitor the user's search dynamics, and then recommend a facet to the user at the most appropriate time. So that's the future plan.
Okay, excellent. Thanks.
I have a question, sorry.
Sure.
Or a comment. A bit of a question. So thanks for your talk first. I think it's in general a good example of information science and also data science. You use a bit of machine learning and for user studies. So I can see where you're coming from and where you are now, and it's a very nice example. I'm just wondering, it's maybe not a question to you, but in general, faceted search. So can we apply all this? I mean, you had product search here, but can we apply all this to what Nick mentioned, for instance, if our refrigerator provides a data stream, and with faceted search and the results that you get from this make sense and can be applicable to when we have really more data. I mean, more data that we usually don't work with, not product data, not documents, data streams or so. Is that something worth looking at, faceted search for data streams? Or as I said, it's not it's a comment and maybe half a question, so it's just.
So my understanding is that So your question is about the live versus static. And then,
for instance, yes.
Yes, are we able to do this, monitor the stream of the data and then do some real-time prediction or real-time recommendation to the library users? Yes, that's something I'm aiming to do. In the NSF project, we actually want to do this a real-time thing, but that there are two parts, offline and online. So the offline part is actually based on the library patrons' history, and then we build these machine learning models based on their history. That's completely static. That's a limited data set. It's a static, and then based on the model, and then we put it online to monitor the live stream of the user search dynamics. So yeah, that's the two parts.
Okay, thank you.
All right, thank you very much. And our session is overrun for 10 minutes, about 10 minutes. So I would suggest we ask the questions maybe through emails or chat box. And we go on a 10 minutes break. It's supposed to be 15 minutes, but if we could come back in 10 minutes time around 3:35, so we can start our next session. Thank you very much. Please.
Thank you.
Thank you.